we will discuss some problems to form the partial differential equation by eliminating arbitrary functions. So the first question is, form the partial differential equation for the function z is equal to y square plus 2f of 1 by x log y. So now in this case there is only one arbitrary function, that is f of 1 by x plus log y. So the resultant PDE will be of first order. So I will take this as equation number 1. So we need only first order partial derivatives. So we will differentiate equation number 1 partially with respect to x and y. So now differentiating equation number 1 partially with respect to x, we have dou z by dou x. So we will write it as a small letter p, that is equal to, now derivative of y square is 0 with respect to x, 0 plus 2 into derivative of f is f dash, 2f dash 1 by x plus log y. Now derivative of 1 by x into log y with respect to x. So we will get minus 1 by x square, derivative of log y with respect to x is 0. So I will take this as second equation. Now we differentiate equation number 1 partially with respect to y. Here we will get dou z by dou y on the left hand side. So we can write it as q. Q is equal to derivative of y square is 2y plus derivative of 2f is 2f dash 1 by x plus log y. Now derivative of 1 by x plus log y, that is 1 by x is 0 plus log y is 1 by y. So now we can rearrange this function. The second function this way, we can write this as q minus 2y equal to 2 into f dash 1 by x plus log y multiplied by 1 by y. This is equation number 3. So now we can see that in equation number 1 there is one arbitrary function f. Now equation number 2 and 3 there is f dash, which is also an arbitrary function. So for obtaining the required partial differential equation, we have to eliminate these arbitrary functions. So then if you are dividing equation number 2 by equation number 3, you can eliminate the function f dash. So then I will divide equation number 2 by equation number 3 now. So we can write 2 by 3. This implies p by q minus 2y equal to, we can cancel 2 into f dash, so that we can write it as minus 1 by x square by 1 by y. So now only simplification remains. So this is the required partial differential equation. So we can simplify this, that is p into 1 by y equal to minus 1 by x square into q minus 2y. So that we can write this as x square p equal to minus y into q minus 2y. Therefore x square p is equal to minus qy plus 2y square, or x square p plus qy equal to 2y square. So this is the required equation. So here p and q are first order partial derivatives. So therefore this is a first order partial differential equation. So you can use any algebraic method for eliminating the arbitrary functions. Here we divided one equation by another equation. Sometimes you have to multiply or you have to solve in the same way you are solving a system of linear equations and all. You can use any method. Our aim is to eliminate the arbitrary function and its derivative. So now we will discuss the second problem. So now it is the second one. So this is the second question. So now in this case we can see that there are two arbitrary functions, that is f1x and f2y. So if you want to eliminate two arbitrary functions, you have to find out second order partial derivatives also, because with the help of two equations you cannot eliminate two arbitrary functions. So therefore the resultant partial differential equation will be of second order. So I will take this as equation number 1. Now differentiate equation number 1 partially with respect to x. So you will get dou z by dou x, that is small letter p. Now derivative of f1x, that is f1 dash x into f2y. Now next is differentiate equation number 1 partially with respect to y. So therefore q equal to f1x into f2 dash y. So we got first order partial derivatives. So now we will find out second order partial derivatives, that is dou square z by dou x square, dou square z by dou x dou y, dou square z by dou y square. So for getting dou square z by dou x square, we will differentiate equation number 2 once again partially with respect to x. So then that is dou p by dou x, and p is dou z by dou x, therefore dou p by dou x is dou square z by dou x square, and then the notation for dou square z by dou x square is r. So therefore r equal to derivative of f1 dash x, that is f1 double dash x, and now f2y is a constant with respect to x. So now we will differentiate equation number 2 with respect to y, so that you will get dou p by dou y, that is dou square z by dou x dou y, and we can denote it by s. So this is differentiating with respect to y. So then s is equal to f1 dash x into f2 dash y. So I will take this as equation number 4, and this is our equation number 5. So now we can obtain one more partial derivative, second order partial derivative, that is dou square z by dou y square. For that we will differentiate equation number 2 partially with respect to, not equation number 2, it is equation number 3 partially with respect to y. So that you will get dou q by dou y, that is same as dou square z by dou y square, and the notation is t. T is equal to f1 x into f2 double dash y. So now this is the sixth equation. See, now we have 6 equations, and these equations, they contain arbitrary functions f1x, f2y, f1 dash x, f2 dash y, f1 double dash x, f2 double dash y. So somehow you have to eliminate all these derivatives and you have to obtain a partial differential equation. Now we can see that from 2 and 3, from 2 you can find out f1 dash x, and from 3 we can find out f2 dash y, and then we can substitute these equations in equation number 5. That is the method we will be applying here. So from equation number 2 we can write, from equation number 2 we can find out the value for f1 dash x, that is p by f2y. f1 dash x is equal to p by f2y. And now from equation number 3 we can find out f2 dash y. So now from equation number 3, f2 dash y is equal to q by f1 x. Next is substituting these values in equation number 5. Substitute in equation number 5, then s is equal to p by f2y into q by f1 x. Now we can see that still it contains two arbitrary functions f1 x and f2y. So how we will remove these two? So we have another equation, that is equation number 1. So by equation number 1, that is z equal to f1 x into f2y. So we can replace this denominator by z, so that from 1, using 1, we can write this equation as s is equal to pq by z, or z s is equal to pq. So now this is the required partial differential equation, and you know that s is dou square z by dou x dou y. So it is a second order partial derivatives, and p is dou z by dou x and q is dou z by dou y. So now after removing these two arbitrary functions, we got a second order partial differential equation. Now we will discuss third question. So that is form the partial differential equation for this one. So here also we have two arbitrary functions. We have to remove two arbitrary functions here. So now this is the question. So then as usual we have to find out all the possible partial derivatives. So differentiating equation number 1 partially with respect to x and y. So the differentiating 1 with respect to y, you will get dou z by dou x, that is p, that is equal to f1 dash y plus 2x into derivative of y plus 2x, that is 2, plus f2 dash y minus 3x multiplied by derivative of y minus 3x, that is minus 3. So this is one equation. Now then we will differentiate the same equation with respect to y, so that we will get q equal to f1 dash y plus 2x into derivative of y plus 2x with respect to y, that is 1, plus f2 dash y minus 3x, then derivative of y minus 3x with respect to y is 1. So these are the two equations we got now. So I will take it as 2 and this as 3. Now then we have to obtain the second order partial derivatives. For obtaining second order partial derivatives, we will differentiate equation number 2 partially with respect to x first, so that we will get r. Dou p by dou x is r. R is f1 double dash y plus 2x into 4, because this 2 and one more 2 comes, you will be getting 4 here, plus f2 dash y minus 3x multiplied by this minus 3, but already there is one minus 3, so that you will get minus 3 into minus 3, that is 9. I will take it as equation number 4. Now differentiate equation number 2 again with respect to y. Then you will get s on the left hand side, and on the right hand side it is with respect to y, so that you will get f1 double dash y plus 2x multiplied by 2, because derivative of y is 1, plus f2 dash double dash y minus 3x multiplied by minus 3. So this is our equation number 5. So now we can obtain one more derivative, that is after differentiating equation number 3 partially with respect to y, we will get dou square z by dou y square, and we will write it as t. So t equal to, so differentiate this equation. So we will get f1 double dash y plus 2x multiplied by derivative of y, that is y plus 2x, that is 1, plus f2 double dash y minus 3x multiplied by derivative of y minus 3x, that is 1. So this is our sixth equation. So now you have to observe all these equations and you have to identify a method for eliminating these partial derivatives. Sometimes you have to use all the equations, sometimes you have to use only one or two equations. Now here, after observing, you can see that if you are adding equation number 4 and 5, you will get the same coefficients. So then I will add equation number 4 and equation number 5. This implies r plus s equal to 6 into f1 double dash y plus 2x plus 6 into f2 double dash y minus 3x. Actually this was f2 double dash. So now 6 is a common factor, so we can write it as 6 into f1 double dash y plus 2x plus f2 double dash y minus 3x. Now then, from equation number 6 we can see that this is the term t, so this is equal to 6t. Therefore r plus s equal to 6t is the required equation. So now we will go to the next equation, next question, that is we have to find out partial differential equation for this problem. So this is the fourth question now. So here also we can see that there are two arbitrary functions, so therefore resultant partial differential equation will be of second order. So I will take it as equation number 1. Now then find out the value for p and q. So I will write it directly here. So dou z by dou x is p, that is equal to derivative of differentiate this one with respect to x, so that you will get 2x fy plus y square g dash x. Now you differentiate with respect to y, we will get q. Q is x square f dash y plus 2y into gx. This is our p and q. Now we will find out r, s and t. R means differentiate this equation with respect to x. So we will get 2fy plus y square g double dash x. Now find out s. S is you will get s by differentiating this equation, that is the second equation, partially with respect to y. So we will get 2x f dash y plus 2y g dash x. So this is my third equation, this is fourth, and this one is fifth equation. So now we can obtain one more second order partial derivative, that is t. So t means dou square z by dou y square. So how will you get dou square z by dou y square? By differentiating q with respect to y. So that we can write here x square f double dash y plus 2 into derivative of y is 1, 2 into gx. So we got one more equation. So now you have to observe all these equations and you have to find out a method by which you can eliminate these arbitrary functions fy, f dash y, gx and g dash x. So here you can see that if you are finding xp plus yq, then you can eliminate these functions. So now xp plus yq means x is multiplied this equation by x. So we will get 2x square fy plus x y square g dash x plus, now next term is yq. So multiply the second equation by y. So we will get x square y f dash y plus 2y square gx. Now then we can combine these two terms, first and last, so that we can write it as 2x square fy plus y square gx plus, and now is find out observe second and third term. So you can see the common factor, there is a common factor, that is xy. So if you are taking the common factor outside, so you can write xy into y g dash x plus x into f dash x. So that is x into f dash y. This is f dash y. So now you see the given question, that is z is equal to this function. We got the same term here. And now here in this bracket we have y g dash x plus x f dash y. You see equation number 5. So these are the terms. So instead of that we can write it as s by 2. So that we can substitute here like this. This is equal to 2z plus xy into s by 2. This is from equation number 1 and equation number 5. So therefore we can simplify it again. So you can write it as 2 into xp plus yq is equal to 4z plus xys. So this is the required partial differential equation. Here you see the partial derivatives are p, q and s. P and q are first order derivatives and s is a second order partial derivatives. So this differential equation doesn't contain the term r and t, that is fine, but it contains at least one partial derivative, that is s. So this is the required partial derivatives. Now there is one more question pending. I want to solve one more question from here, that is the last one, that is this one. Okay. So this is the fifth question. So now we can see that this equation, there is some difference in this equation. It is of the form f of u v equal to 0, where u is x square plus y square and v is z minus xy. So such type of equations actually we can rewrite in another form. So we can write it as, instead of f of u v equal to 0, instead of that we can write it as u as a function in the variable v. In this way we can write. So therefore we can substitute the value u as x square plus y square. X square plus y square is phi of z minus xy. Now then, this function and this one, the given question, they are same. So now you see the equation number 1, it is an equation which contains one arbitrary function. So then we can apply the same method which we have used in all other problems, so that we will differentiate equation number 1 partially with respect to x and y. Since it contains only one arbitrary function, the resultant PD will be of first order. Therefore, it is enough to find out P and Q. Now differentiate equation number 1 partially with respect to x, so that we will get 2x plus derivative of y square is 0, that is equal to phi dash z minus xy multiplied by derivative of z minus xy, that is p minus derivative of x is 1 into y. So that is one equation. Now the second equation is obtained by differentiating 1 partially with respect to y. So you will get 2y equal to phi dash z minus xy into derivative of z minus xy with respect to y. So that you will get q minus derivative of xy is x, that is with respect to y. So we will take 2 and 3. Now then, observing easily we can see that if you are dividing equation number 2 by 3, you can eliminate the arbitrary functions. So now equation 2 by 3 gives 2x by 2y, left hand side we can cancel 2, constant 2, so that you will get x by y equal to p minus y by q minus x. Actually this represents the required partial derivatives. Now then only the simplification remains, so that we can write it as x into q minus x is equal to y into p minus y, or we can write it as qx minus x square equal to py minus y square, and that is same as qx minus py equal to x square minus y square. So this is the required partial differential equation. So then if the given question is of the form f of x square plus y square z minus xy equal to 0, so we will rewrite this function in this form. That is what you have to remember. Actually f of uv equal to 0 means it contains only one arbitrary function, but it contains two variables. So it contains one arbitrary function of two variables. So then after rewriting this one, this also contains only one arbitrary function, but it contains only one variable. That is the conversion which we have done by this one. So then after that use the same procedure, so that you will get the required partial differential equation.